The vapor compression cycle is a widely used thermodynamic cycle that forms the basis of most refrigeration and air conditioning systems. Its primary goal is to transfer heat from a low-temperature region to a high-temperature region. This is achieved by circulating a refrigerant through a closed system, where it undergoes phase changes from liquid to vapor and vice versa at different pressures and temperatures. Here's a breakdown of the four main processes in a typical vapor compression cycle. The compression process. The low-pressure, low-temperature refrigerant vapor enters the compressor. The compressor is a mechanical device that increases the pressure and temperature of the refrigerant vapor. Work is done on the refrigerant during this process. The refrigerant leaves the compressor as a high-pressure, high-temperature vapor. Condensation process. The high-pressure, high-temperature refrigerant vapor flows into the condenser, which is a heat exchanger. Heat is rejected from the refrigerant to the surroundings. As it loses heat, the refrigerant changes its state from a high-pressure vapor to a high-pressure liquid. Expansion process. The high-pressure, moderate-temperature liquid refrigerant passes through an expansion valve. This valve creates a restriction in the flow, causing a significant drop in the refrigerant's pressure and temperature. The process is essentially at constant enthalpy. The refrigerant leaves the expansion valve as a low-pressure, low-temperature mixture of liquid and vapor, ready to enter the evaporator. Evaporation process. Low-pressure, low-temperature liquid refrigerant enters the evaporator, which is a heat exchanger. Heat from the space to be cooled is absorbed by the refrigerant, causing it to boil and change its state from a liquid to a low-pressure, low-temperature vapor. This process cools down the air or substance passing over the evaporator. In summary, the vapor compression cycle works by using a refrigerant that readily evaporates and condenses at practical temperatures and pressures, increasing the refrigerant's pressure and temperature through compression, releasing heat in the condenser at high pressure and temperature, reducing the refrigerant's pressure and temperature through expansion, absorbing heat in the evaporator at low pressure and temperature. This continuous cycle allows for the efficient transfer of heat from a cold environment to a warmer one, making refrigeration and air conditioning possible.